Okay, question 6 uses standard results for r squared and r to show that the sum between 1 and n of 3r minus 2 squared is equal to that. So, the sum between r is equal to 1 and n of 3r minus 2 squared is equal to the sum between r is equal to 1 and n. The first thing to do is to times out that bracket. 9r squared minus 12r plus 4, and that is equal to 9 times the sum between r is 1 and n of r squared. Take away 12 lots, the sum between r is equal to 1 and n of r, plus 4 lots of the sum between r is equal to 1 and n of 1. Now we can use our standard results that we know to write that as 9 times a sixth n plus 1, 2n plus 1, take away 12 times a half n plus 1, plus 4 lots of the sum of 1, which is just 4n. The rest of this now becomes an exercise in timesing out brackets and rearranging stuff in order to get the answer that you want. It always pays to look to see what we're trying to aim for here. We obviously want a half to crop up and an n to crop up, which at some point we want to whip it aside, all of this. And then hopefully whatever's left over we can massage to become 6n squared minus 3n minus 1. So if we try to massage all that together, how shall we do this? Well, let's whip out the half n to start with, because we can. The half n, so that means the 9 is left, which I need to get from that 9 there, and there's a 3 for that 6. 2 and 3 makes a 6. The n's already taken care of. n plus 1, 2n plus 1. That half n, there's a half n on it I whipped out, so that leaves me with a half, 12 rather, n plus 1, and I whipped out a half from that, which means that must therefore now be just 8, because a half n times 8 is to 4n. I then ponder what to do to this, and I think to myself, well, I know I'm trying to get a quadratic out of it, so probably best bet is just to times the whole thing out and see what happens. So I'll keep that little square bracket there for the time being. That's 3 lots of 2n squared plus n plus 2n plus 3n plus 1, take away 12 lots of n plus 1 plus 8, which is a half 6n squared, well, that's promising, isn't it? Plus 9n plus 3 minus 12n, well, that's promising. Minus 12 plus 8, does that seem promising? 3 take away 12 is minus 9, minus 9 plus 8 is minus 1. That seems like it's a half n. That's the way to lose a mark carelessly. 6n squared minus 3n minus 1 as required. Okay, part B, hence. Find any values for n for which hence is a command word telling you to use to your previous result. Now there's 2 bits going on here. There's this bit, the sum between 5 and n of that, and then there's this bit, 103 times the sum of all of that malarkey. And there's a 3n cube, which in fairness we can sort of deal with. It's probably best to deal with these 2 things separately and then join the idea together at the end. The first one, the sum between r is equal to 5 and n of 3r minus 2 squared is equal to the sum of r is equal to 1 to n of 3r minus 2 squared, take away the sum of r is equal to 1 to 4 of 3r minus 2 squared. This bit we know what it is, a half n, 6n squared minus 3n minus 1. This bit we know what it is, a half of 4, 6 times 4 squared, take away 3 fourths, take 1. That's what we call a sum, so that means we can sort of work out what that is, and then that bit's job done. Let's work it out just very briefly. 2 times 6 times 4 squared, take away 3 times 4, take away 1, is equal to 166. So that's 3n cubed, take away 3 over 2n squared, take away a half n, take away 166. That's the first part done. Now this second part. The 103 times the sum of all of that. The 103, let's not ponder about that too much, it's 103, we can deal with that later. Let's just think about this thing here. R cos r pi over 2. The sum between r is equal to 1 and 28 of r cos r pi over 2. What on earth could we do? Well, at the very least, we could work out the 28 numbers and add them up. They're all numbers, there's 28 of them. Okay, it might be a tad tedious, but we can certainly do it. Let's go back into radians, menu setup, angle unit, radian. So 1 times the cosine of 1 times of 1 times pi over 2 is equal to, okay, that's 0. And then let's go back and edit this to be a 2. That's minus 2. And then let's go back. Now, you may be thinking to yourself, this seems frightfully tedious to be doing this in the exam. How on earth? Oh, that's a 0. Do I really have to do this? Well, the answer is no, not really. I mean, certainly, for the lack of any better ideas, this would be a good thing to do, and I certainly would recommend it. Hopefully, though, at some point in the process, before you've done all 28 of them, you might start thinking to yourself, hang on 1 second, maybe, just maybe, there's some sort of pattern going on here. Zero, minus 2, 0, 4, minus 6. Okay, I paid a bit good money then, next one's going to be 0. Oh, it is. This one is 8 plus dot dot dot. So there's clearly some pattern. 0, minus 2, 0, 4. 0, minus 6, 0, 8. These ones add up to be 2. This set of 4 adds up to be 2. Altogether, there's 7 sets of 4 in 28 terms. So, therefore, I can deduce that the 7 4s are 28. That the sum of those terms is going to be not 28. I managed to do the wrong sum. There's 7 groups of 4, and there's 7. Each group of 4 adds up to 2, so 7 2s are 14. However, it's not that, because there's a 103 times the sum of that, so it's 103 times 14. So now I can put it all together. I got my first bit, 3n cubed minus 3 over 2 n squared minus a half n minus 166. The second bit is add on 103 lots of 14, which is the sum of that series there. That's equal to the third bit, which had a too little 2, 3n cubed. The 3n cubed is cancelled. I can do a bit of rearranging stuff, and I can end up with a quadratic 3n squared plus n minus 2552 is equal to 0. Once I get as far as the quadratic, it's then just a case of solving it. And I can either solve it, I suppose I could use the quadratic formally, I could complete the square, I could do all sorts of bonkers things, but instead I'm just going to type the coefficients into the calculator. 3, 1, minus 2552, and we get 29 and something minusy. The minusy is not going to be the answer, because we can't have a minusy number of terms. So the answer is n is equal to 29. Either don't write down the minus 88 over 3, or if you do write it down, make sure it's fairly obvious that you've decided to reject it as not being a valid answer.